We're going to talk about object-oriented programming in Python. Um, there's a lot of different ways to organize your world as a programmer, and that's really what programming is all about. How do I want to organize my world? And so the software engineering community, the computer science community has come up with a lot of different approaches or paradigms. A popular one, not the only one, but a popular one is object-oriented programming. This idea of objects, which is sort of like if we have code and we have data and we kind of combine them together, we maybe get an object. And Python is known as what's called an object-oriented programming language, and everything in Python is actually an object. So this is really fundamental to the language and a really fundamental concept in programming and computer science. And we are just going to scratch the surface of it. This is a semester-long course, so these next several days are very much about the highlights. So we're going to do an overview of object-oriented programming. We're going to talk about this idea of classes, of organizing our world, how we model the world in our program into classes. We're going to learn how to create new instances of a class, objects, with this special init method and this special property called self. And we'll learn about Dunder methods, which is short for double understring or double underscore. And this is going to show up in our first graded assessment, which will be released at the end of this week. Any questions about what we're covering this morning? Awesome. We're also going to look a little bit at what's called getters and setters and properties. So there's a lot of good stuff that we're going to cover. Can I get a volunteer to read this for me, please? Not a trick question, I promise.
Sure.
Thank you.
Object-oriented programming is a programming approach that organizes code around objects, which are representations of real-world entities. It focuses on breaking down complex problems into smaller, manageable pieces called classes that have properties or attributes and behaviors, methods. By using object-oriented programming, we can create reusable code, promote code organization, and simplify problem solving by modeling the relationship between objects.
Brandon, awesome. Thank you, man. And just out of curiosity, can I get a quick show of hands? Who here has done a little bit of object-oriented programming or been exposed to it before? And I know a couple of folks have, and many folks have not, and that's exactly why we're here today. Okay, so I see a couple of folks were introduced to it, which is awesome. Definitely going to leverage that as we get into this. I'm going to do a little bit of talking with the slides for maybe 10 minutes, and then we're going to get into really writing code and talking about it. So there's a little bit of concepts and talking up front, and then I'll be writing code and we'll be talking about it. And Cody, yes, sir, did you have a question? Oh, the hand was up from before. Perfect. Okay, so a big concept in object-oriented programming is what's called a class. And you can think of this as a blueprint. Like if I, need to build a bunch of new iPhones, I don't know if you can see me waving my phone here on the video share. I need a blueprint for it. And I can build many different iPhones off of this blueprint. The idea of a class is like a blueprint, and it will hold data and logic. So data and functions. And when I say data and functions, what do I mean? Can everyone see my screen?
Yes.
Perfect. Thank you. And I'm going to go ahead and close this out because we aren't going to have a lot of different files. And is this font size okay with everyone?
Yes.
Okay, I'll make it just a bit bigger anyway. So Or let's just say, let's make this simple. Right, I've got data, I've got information or data that I'm storing in my program, and I've got logic. And it would help if I wrote this as a proper Python else if. And I can mix the two together, right? And in fact, if I wanted to, I could have maybe a variable, and I could print that out here. And so I've got data, and I've got logic. And pretty much everything I do when I'm writing code is going to fall into one of these two categories. And the more and more you write software, the more you realize the data and the shape of your data. Like maybe we actually, for some reason, we want a Python dictionary, like I don't know, messages. This wouldn't be a very good way to do that, but that my data becomes more important than my logic and how I organize my data. So this idea of a class and objects, we're going to create a blueprint that lets us combine like relevant data and logic together, which sounds a little fuzzy, but I think when you see it in action, you'll kind of see what I mean. The big concept here is we want our code to be organized. We want our code to be modular, because as our programs get bigger and bigger, these things become more important. So I can have a class, and I can have what's called an instance of that class, just like I might have a blueprint for an iPhone. But then I can create, like hundreds of iPhone SEs like mine, and then each iPhone SE can have different stuff on it. So I have like a blueprint for a class, and each instance of a class, then they're all iPhone SEs, but they all have their own internal differences. And that's what we're going to learn and talk about more in just a minute. Let me just pause and check in and see if folks have any questions. Okay.
So I have a question. So what you mean is the OOB is we combining the data and the algorithm, right? The code.
Yes.
And the class is the combining of data and algorithm, different code with data together, right? So we have different OOB to make something, the whole project, right?
Exactly. And I
Thank you.
think
That's it.
Great question. And in just a minute, I want to talk just for another minute about concepts. And then I think once we start writing code, it will help illustrate that really well. So there's these 4 ideas of OOP that are called the pillars. And I just want you to file these away in the back of your head as we talk about them. Encapsulation, abstraction, inheritance, and polymorphism. Please just go ahead and write these down. In practice, you'll just see the more you write code, the more it's easier to start to put these into practice. Part of the idea is encapsulation, that some things can be organized separately from the rest of my code. So I can have one class that just deals with one thing. Kind of related to this, and maybe certain data that the rest of my program doesn't need to directly interact with. Related to this, classes help me create good abstraction, where this stuff is so complex that sometimes I don't need to know all the details for instance, if I'm driving a Tesla, I don't need to know exactly like all of the electrical engineering behind how the steering wheel works. I just need to know if I turn it left, it goes left. If I turn it right, it goes right. Inheritance, which is where we can have classes inherit from each other. And once we start, we'll see it a little later, I believe this week, but it can make design easier, though it can also add some complications, but sharing of similar features. And then something called polymorphism, where you can have objects taking on different forms depending on what they need to do. Like, for instance, I might have an iPhone SE and someone else might have the new iPhone, I don't know, 14 or whatever, and someone else might have an Android, but all of our phones can make a phone call, right? Maybe what happens is a little different because each phone has a different form, but we all can make a phone call. And this is probably a good point to pause and start writing some code, because now we start to dive into some other stuff. And Brandon, yes, sir.
I'm looking at the notes on curriculum, and there's a fifth one that says composition. I didn't know if that was essential.
Oh, did I miss composition, or is it not in the deck?
It's not in the decks, but it is in the notes on
Oh, yeah.
curriculum. Yeah.
Thank you so much for pointing that out. That is a good one to talk about. And we'll see this again, like composition, we see a bit more later in the week, but we'll see like once we are creating objects or like objects that are instances of classes, I can build up a class out of other objects. Just like maybe if I have a really complex airplane, there's one blueprint for the engines, one blueprint for the cockpit, and then maybe a giant master blueprint that says, refer to, engines blueprint or something like that. And there's this idea of inheritance where something is or belongs to something versus composition where something has something. And when we cover these, we're not going to cover these a lot today, but when we get into them more in the week, we'll see them in action. So I've been talking about this, but let's go ahead and see what this means in practice. So everything in Python is actually an object. And in fact, I'm going to pull up ChatGPT to help me remember to make sure I get the Python type command right. And I think it's just type, and it's going to tell me when it's done talking. But I'm pretty sure we just use type. And indeed we do, but it's like, why, if I can double check it, why not? So let me go ahead and let's comment out this code so that stuff doesn't get printed. And let me just go ahead and run this. And note that for the number 5, it prints out this message and it says class, and then in single quotes, int, which is short for integer. So an object is an instance of a class, right? So I might not have realized it, but when I use the number 4, I'm actually instantiating a new instance of the integer class. And it would help if I used type there, because I want to print the type. And we see that it's an integer as well, right? And if I did hello, we can see that's an instance of the string class. And if I print true, we should see that this is an instance of bool, which is short for a Boolean variable, as in true or false. And even functions, I believe, are classes. If I do something like, let's do def hello world, and we'll just have it print hello, and let's do print type hello world, and let's see if I'm right here. Even when we create a function, it's an instance of this class function. So, when we say that Python is an object-oriented programming language, hopefully this starts to illustrate what that really means, that really everything in Python really is an object. JavaScript is kind of, sort of, but not quite this way. And as we've seen, an object is an instance of a class, and there are certain things that you can do with different classes. And we can see some interesting stuff later, but I think the good part is let's create some classes of our own, right? And kind of like we have here in the curriculum for today, let's create a class named dog. Kind of shapes and animals are the classic ways to learn object-oriented programming. So we're creating our own blueprint now. And this by itself is all I need to do to create a new class. It's not going to do much, but it exists. And if I want to create a new instance of it, I have to do what's called calling the class's constructor. Because we'll talk about it in just a minute, but when you create a class, there's an initialization method or a constructor method. And just like if I was calling a function, to actually execute that function, I need the parentheses with whatever arguments I'm going to pass. We do the same thing with the class, except Python is doing some of the work here for us. Now, there's not a lot interesting to see about my dog at the moment. We get this message printed out. This is Python's way of saying this is an instance of the dog object. This is actually that instance of the dog object's location in memory. And if I go ahead and I look at the type of my dog, fingers crossed, it should say dog. Now, most of the time when we're creating a class, we're going to want to create what's called an init method, or you'll hear this called a constructor method. In Python, its name is init. In other languages, its name might be constructor. Init is short for initialize, right? And think of constructor as in to construct or to create. Like if we have our blueprint, this actually creates the thing from the blueprint. And these double underscores in Python are what are referred to as dunder. And you'll hear these kinds of methods called dunder methods. And we shouldn't be creating methods with our own names. Like init is a special name that Python knows. And that's also why we're going to use the double underscores, because that's the naming convention. So Python is going to do some special stuff with this method. And it looks a lot like a function, right? I'm calling it a method, but it looks an awful lot like a function. And it behaves an awful lot like a function, except we are creating it as part of our dog class, where we're going to see how this starts to help us combine logic and data. And just for fun, I'll put a print method there. And so now watch what happens when I run this code. And we have this print statement, new dog created. And let me comment both of these out and just run line 32. And let me comment these out so they're not cluttering stuff up, actually. so that all we should see is line 32. And so someone explained to me, when I run my code and like my code gets here to line 32, where's it going next? Eric, yes, sir.
So when you instantiate my dog, it goes to the dog class and then it automatically runs your init method.
Exactly. You hit the nail on the head. And I'm a little rusty with the Python debugger. Let's see if this works. Yeah, I'm not gonna worry about this right now. We'll try and find a different time to demo the Python debugger. I use it so rarely that I'm just rusty with it. I normally use print statements. The debugger actually lets you pause your program as it's running, where you click on what's called a breakpoint and you can see all the values of everything. But like Brandon was saying, what happens is I run my Python program scratch py, and Python's going from top to bottom. And when it gets here, just like with the function definition, it's not executing any of this. It's just putting it off to the side. Here, though, it says, oh, what's going on? We're creating a new instance of the dog class. Let me pull up that blueprint. And the first thing I'm going to do is run this special method, right? Very much like a function named init or dunder init. And the first thing that happens there is this print statement runs. Brandon, yes, sir.
Oh, I was gonna say you can type like breakpoint and then parentheses, and then that loads the Python debugger into your console. And you can do print statements for whatever you're trying to print for. But we're a little past that, sorry.
Oh, thank you. That is like that.
Yeah, and then it'll load the Python debugger into your terminal.
Learn something new every day.
Yeah, I will. Oh, what did I somehow get navigated out of there?
So
Oh.
now you can type N to go to the next step. It's gonna have the breakpoint exactly where you put the breakpoint. Then you can do P to print whatever.
Yeah, that is cool. It's a little more than I want to get into right now, especially just because I don't use it enough that I'm not comfortable enough to show it fluently on the screen. That is really good to know, though. I will try to demo like full on the debugger because I would like to show the visual one as well. But for now, it's not critical for us. Though that is very useful to know for sure. So let me just pause here real quick and check in and kind of see if folks have any questions around what we've covered thus far. Okay. Oh, Chris, yes, sir.
So, what's the point of doing a class? Is this to compile a bunch of functions so you can just call that class in another file, or how? What's the what would you use a class for?
Yeah, great question. We would use it if I want to import code from another file, and we're just going to use it more and more to organize our code. And I think what will help illustrate that is let's start doing more stuff with this class. Like, let's give our dog a name.
So the way I like to think about it is like, remember how in Python you had like dictionaries and stuff? Well, imagine if dictionaries were like upgraded to have like functions attached to them. And also on top of it, they also have data too. That's kind of like what a class or an object is.
Thank you.
Yeah, great way to say it. And in fact, let's just go ahead and so let's give my dog a couple different properties. this variable and this variable do not have to be the same. I could have this be like dog name. But often you'll see them named the same. I'm going to name them the same because it makes it easy when I'm reading this code to see what's going on. And let's give our dog some properties and assign these. And in fact, I need to use this self keyword to go ahead and do this. And let me talk about what we're doing. And I'm going to go ahead and use an F string and just say self name is what am I doing wrong with my F string? Do I need a $sign up front? Oh, I need to pass self as an argument. So now if I've got my dog and I can create a dog and we're gonna create Fido. And just like with function arguments, the order of the arguments matter, unless we're using named arguments. And Fido will be a Labradoodle because my parents have a standard poodle, and will be brown, and the sound will be roof. And we might as well name Fido to Fido. Here, and let's actually put this here so that my dog can stay. Sorry about that. I kind of lost. And let's run this and see what happens, and then we'll talk about it. And name, breed, color, sound. Let's see, what did I do wrong here? Though I did not do this one on purpose. Oh, I see. So this is actually a good thing to point out. I made a really easy mistake to make. When we first created the dog class, we were not passing any arguments to this init method. But now that we are, look at the error message that it showed me. Dog init on line 41. So I know that the error is coming from this line in my code. Missing 4 required positional arguments, right? That these arguments, name, breed, color, sound, they're required and they're missing. So Python is throwing an error. There are ways to make arguments optional, but we're not gonna, I think we looked at them a little bit last week. I'm not gonna go into them right now. And so now I should be able to run this, and now my code should run. And now we get Fido, and Fido says hello. So what just happened here? This stuff, these arguments, that feels kind of familiar, right? And passing them in here feels kind of familiar. Calling a method kind of feels like calling a function, right? But what's up with this self stuff? So we talk about classes, right, and objects, and I talked a little bit about instances of class. And this term, an instance, is really important because it's going to come up. We created an object of type dog. If I type out Fido, if I do print type Fido, we'll see that Fido is indeed a dog. Right, so an object is an instance of some class. And the way that Python works is when I'm creating this blueprint for my class, I need to be able to tell it like what belongs to this class when I create a new instance of it. And that's what this special variable self does. And I kind of think of it almost as like a skeleton, like, you know, the muscles and the rest of our body like sits on top of the skeleton. Well, a little bit under the hood, the way you can think of self maybe is as like the skeleton of a class in Python. And so I can create an instance method for my class. This is a method or a function that any instance of my class can run. And then I can create instance attributes. You'll also hear people call them instance variables. I can create these values that belong to that instance of my class, right? Because if I have Fido, but then I also make Rover, and Rover is, I don't know, a German Shepherd, and I guess also brown, because I don't know if I can think of what other color a German Shepherd would be. Rover is different from Fido, right? And so logic, some simple logic here, but still logic about what I should say and in what order, and data combined together. And this special attribute or value self, we have to pass it in for our init method and for every instance method in our class. And when we want to access an instance value, we do it like this with what's called dot notation, self dot breed, self dot color. And here you can see we're setting the values of those things. Like if I, you know, just changed this to, you know, same name always, or instead, I don't know, I changed it to null for some reason. And I believe I actually want it to be none. I was thinking of JavaScript there. Then all instances of this dog class now have none as the name, which obviously is not something that we want. So this is probably a good stopping point to check in and see what questions folks have or what's on people's minds. Daniel, yes, sir.
So the word instance is only towards objects, right? We should never use instance variables for anything outside of objects.
Yeah, try not to. Yeah, good question. Polly, yes.
And so for the first one, self never changes. That will always stay the same. Just the last four will, you can change their different variables.
Yes, exactly. We always need to include self, even if I didn't want to have any arguments at all. I think you would be able to maybe not use self if we don't use it anywhere, but just to start out, you should probably always put it there. It always needs to be the first argument. And you can think of Python under the hood of doing something with self, because let's say, you know, let's say I make a function, give treat. Self is the first argument here, and passing it in, and then note that we also need to use it if I want to like access any of these instance attributes. But then when I call this, like if I say, you know, Fido, give, treat, phone. I don't need to pass an argument for self. Python takes care of this first method. So it's a little confusing at first, but if you think of it as sort of like self is for the house, self is for Python to take care of, like the rest of these arguments are the ones that we need to worry about. Does that make sense and help illustrate it a bit?
Yes.
Awesome, great question. Brandon, yes, sir. Oh, Francisco, yes, what's up?
Hey, so just to clarify, self is just so once you turn something into a class or you start writing a class, everything within that class, as far as methods go, the very first argument will always need to be a variable that references the class instances itself. Is that right? So like technically as that first argument always needs to be a reference to the class instance. Is that right, Adam?
I think so. We're talking about when we're defining class methods.
Well, the init method is just a class method, right?
Yeah,
So that's what I'm talking about. So an easy way for everybody to know is just whenever you write a method within a class, because of the fact that it is a class, it knows it's going to create instances. So you need to ensure that you have a way for it to reference the instance itself. And that's why self is like the industry standard for Python, where I'm sure other people are accustomed to or have seen other languages that write OOP, they utilize this. Well, in this case, Python, we're always going to utilize self to reference the instance of a class itself. I hope that didn't come out confusing. Thank you, Adam.
no, thank you, man. And we sort of see that here where this method doesn't take any arguments, but I still need to pass self. And if I didn't, and in fact, let's go ahead and remove it. First of all, I get all these red squigglies telling me maybe that something isn't going to work. But if I run my code, let's see what happens. So we get this error, dog say hello takes 0 positional arguments, but 1 was given. Which seems a little weird because if I look at Fido, say hello, I'm not passing any arguments here. But just like Francisco was saying, what Python does is every time one of these class methods is called, it's actually passing in self for that instance of that class. And then that's how like I can use self inside of it. And that's kind of how this stuff is built. Like Francisco was saying, I think like with Java or JavaScript, you would see this instead of self. But so Python is actually trying to pass in here for Fido the instance of the dog class of Fido, that self value. And I think it's a dictionary or something under the hood. But because we still need to manually define that this takes it though. Eric, yes.
I was curious if you tried to print self, if that would work, and would that just give you like, would it say that's if you print self, does that just give you output of Fido or whatever the class instance is?
Great question. Let's find out. So let's go ahead and print self right here after we print Fido. And let me go ahead and clear the terminal. And let's why don't we comment out this other stuff just so we can see what's going on. Okay, so somewhere previously in my code, I'm printing out an integer. I know that this print statement new dog created is from my constructor from whenever I create a dog from that Dunder init method. So I know that this next line must be from print self. And what we see printed out here, in fact, is information about that specific instance of the class. Like for fun, let's have Rover print self. And we can watch this be slightly different. And we can see that Rover and Fido are both instances of the dog class, but live in different locations in memory. And in fact, this is jumping ahead just a touch, but another sort of built-in Python method that you can create for every class is dunder str, which is short for string. Because now that we're creating these sort of more complex things, these classes, it's not just the dictionary, and Python doesn't necessarily know what information we need or care about. So we need to actually tell Python, like, hey, if someone wants to print this out, what should I say? And now if I run this, let's see what the second error is from. I'm seeing line 58 and 42. So one of these worked, but then the second didn't. So this is what I expected. Fido is a Labradoodle and said roof. But then I see in print self, there's an error on line 58 in print self, and then another error coming from line 42. So this tells me that when you're looking at error messages, you usually want to start at the top or the bottom. And it's called a trace. And in this case, I can see the error initially occurred on line 58 here with this print statement. But then I'm getting a trace back of the error and it's saying, hey, actually line 42 that got called on line 58 is what's causing this with this print self right here. I'm actually not certain why that happened, to be totally honest. Let's try commenting this out. And here, let's just print Fido and see if we get an error or not. Chances are there's a typo. Ah, I made a simple mistake. So the way I debugged this, by the way, is I simplified. I cheated a little bit because what we're about to learn is this dunder string method. What it does is if I print out an instance of an object, Python looks for the dunder string method and runs it. But I see here that the type error that gets thrown is dunder string returned non-string. And this was my mistake in creating this dunder string method. I'm printing, but when you use methods defined elsewhere, you have to follow the pattern that they set. And we could look this up in the Python docs, but this dunder string method, Python expects it to return a string. And so now, fingers crossed, if I run this, this looks like something silly. I have an unmatched parentheses because I deleted the print statement. So that is a good example of the dangers of copying and pasting. And now I think we're back in business. And now I think my print self method should work. And now we're cooking. So it was a little bit of a detour, but we saw that this dunder string method is, again, any of these dunder methods are special methods that like Python expects to exist and will handle in a certain way. And when I'm creating a class, if I want to be able to print out information about that class, I need to create a dunder string method that returns a string. And then whenever I print that instance of that class, that's what we'll see. And in fact, we saw that that is printing out self. as someone else was asking about, because right over here, this print self method, we just go ahead and we print self, and that this does the same thing effectively. And Brandon, and yes, sir.
Yeah, so I just wanted to add that for me personally, learning about strings, the whole self thing, the best thing that I can relate to is like if I was talking about myself in the third person. And that's what self is to me. So if I'm working inside of a class and I call self, I'm just speaking about myself in the third person. So if someone were to say, "Hey Brandon, what's your favorite color?" Brandon's favorite color is blue. And that really helped me with self in classes.
Nice, I like it. I think that's a good analogy. And we can do a little drawing on TL draw too. I think someone else had a question that I might have missed earlier, so I just want to check in. Okay, and let me do a quick catch up on our X-ray questions channel. Yeah, Francisco, thank you for the explanation. And just to reiterate, self is a reference to the instance itself. Raven, you had a question. Since you can have more than one logic, how do classes usually have an initial init instance? And I see there were a couple of answers here. And I think the question was, can I have more than one dunder init method per class? And the answer is no. You can only have one. When we learn about class inheritance a bit later, we'll see how we can use that. I think a good point for us here, because we covered most of this stuff. Let me just do, let me print something out real quick, and then do a quick TL draw to talk about self, and then I think that'll be a good time for us to take a break. So we've been printing all this stuff. What if we print like the class itself, not an instance of the class, but what if I print dog? And let's put a little message here. I like to make sure I can tell where I am in my print statements, so I'll often add little messages to myself. And I can see that the dog class is, it is itself a class, right? With this Dunder main thing after it. And, what if I do dog what do folks think is going to happen if I run this code? What do folks think is going to happen on line 171?
It's probably gonna bitch at you for trying to having a second instantiation, I think.
Close. I've already instantiated an instance of my dog class here. I've instantiated another here. I named it Rover too, but let's just say we named it like Sparky instead. So there's no problem with that. We are going to get an error. But it's going to be, I think, for a slightly different reason.
Well, there can only be one class constructor. Oh,
Well, you're correct, but our class only has one dunder init method right here. I'm just trying to call it here, but I did this on purpose because this doesn't actually work. So I apologize because it was a little bit of a trick question. It this is maybe not the best way to illustrate it because we're actually going to talk about class methods later. But the reason that we call these instance methods and instance attributes is because they only exist on an instance of the class. Like if I try to print dog color, this dog does not have a color because I'm trying to interact with the class itself. And I think this might be a good time to do a quick TL draw, and then probably a good break. So as Francisco was saying the other day, we can think of everything in terms of boxes. And let's go ahead and make a dog. And just for simplicity, let's just give the dog a name and sound. And let's just give it a say hello. And let me go ahead and make my instances in blue. I should probably put Rover in quotes here. And so just to kind of help illustrate this a bit. I've got my class here in red, but I create my instances here in blue, and I can have multiple different instances. So I don't know, I hope that TL draw helps a little bit, but seeing as we're just a little bit past the hour, this is probably a good point to pause and check in and see if folks have any questions, and then we can do, I think, a little bit of work time before the second part of the lecture. So let me just check in and see what's on people's minds. Brandon, why? Yes, sir.
Sorry, does the name need to be self.name in the dog class initialize the init?
Oh, you mean here?
In the class he's saying.
In the red.
Oh, yeah, it absolutely does. I'm so sorry. Thank you. Yeah, I have a couple typos hiding here. So let me go ahead and fix this. Self.sound. And I used name twice, so let's fix that too. Thank you so much. Eric, yes, sir.
I don't know if this question's out of scope, but when is it appropriate to use class attributes versus instance attributes?
Yeah, great question. We are gonna talk about class attributes more tomorrow. I think the short version, folks, is a class attribute is if I want all dogs to always make the same sound, I can do that as a class attribute instead of an instance attribute, which we'll learn about later. And the short answer is when you have something that you really want all the instances of that class to either be the same for or have access to. Does that help answer your question a bit, Eric?
Yep, thanks.
Totally. Like sound is a good example. Like if we wanted to, we could say all dogs will always say bark and maybe define that as a class attribute. And instead of letting each dog make its own sound.
I would actually say be careful using class attributes because it's effectively like having global state. Because all of the objects share the same state. So if you mess with it, it can make the program very hard to understand and to debug later on. So stick to instance state usually.
Yeah, we do have you folks use a decent amount of class attribute stuff over the course of the week and for the assessment to get familiar with it. And I don't want to get too into the weeds on it now, but that is good advice. Certainly for today, obviously, we're not covering class attribute stuff. And I think the starting point is to just think about kind of like creating good, simple classes. Okay, awesome. So let me go ahead and show you all kind of what we have lined up as an assignment. So the plan is, I think we should be able to get like an hour of work time in. And then after that, we're going to learn about getters and setters in Python and something called decorators. So another feature of object-oriented programming. But for the next hour, I'd like you all to take like a 10-minute break and then work, you know, if you want to work with your team, you can. I think this could be a good group coding activity. If folks want to work individually, that's okay too, but I do want people to be writing code on these first two assignments and see how far you get. And I would start with this one, app users one. And Connor, in fact, has written some tests for it. So you can see that this is relatively straightforward. We want you to create a class named user. And then we want you to create some different users. And a user should have a name, an email address, maybe a driver's license, whatever you want to add. So there is some flexibility. We do have some tests here. So you can see an example of a user with note that this user, we're creating different instances of this user, and this user just has a name and an email. So you can and should add more properties to the user, but we just wrote tests for the first couple things. And like, here's actually a driver's license as well. And I think Connor slipped a couple, or Rich, excuse me, slipped a couple Easter eggs in there. So we just want to get you all comfortable just with creating some classes and instances of classes. And then if you finish that, we'd like you to move on to building a guessing game, which is going to be pretty simple. And we give you some instructions here on how to do it. And note that in the instructions, we tell you the names of the different methods on the class that you should create. When you see documentation, you'll often see class name, hashtag, method name. And you can see here in an action where I've created an instance of the guessing game class and I'm calling the guess method. So here we're giving you a little more specificity as we're giving you some methods. We're telling you specifically like what each method should return. And I believe there are now some tests here as well that you can use as a guide to help write code to pass this. So that's really the plan for the next hour. And then at 11 Central, we'll reconvene and do part 2 of our lecture, which we will look at getters and setters in Python. All right, so we're going to go through this app users 1 assignment. And I think just sort of, there we go. And I think I'm going to ask for some help to code this up, just to do a little bit of group coding. And I'm going to sort of talk through how I read one of these readmes. and build out this assignment. And I love the split screen. And can everyone see my screen okay with the font size and everything? Cool. I love the split screen, though not the horizontal split. I like the vertical split. And what I like to do is I've got my code here. So most of the assignments have tests, and Rich, thank you for adding these tests. And as you learn more and more about tests, and actually this is really important for the assessment because the graded assessment will have a test suite that you'll have to pass. So learning how to read those tests is really important. So as we've learned with PyTest, I know that each of these functions is an individual test, right? And if I look through here, I can actually see a lot of hints. I can see that this user class needs to take 2 arguments. And just from kind of like looking at what, you know, strings we're passing, I can see this first argument is a name. The second one is an email. I can see that the tests are expecting there to be on this class when I create an instance of it, an instant attribute named name and email and driver's license. I can see that there should be some sort of default value for driver's license, that it should be an optional field. And that's about it, really, because this is a pretty straightforward assignment. But just taking that time to read through these tests really, really helps, right? And in fact, I'll go ahead and I'll make a split with this as well. And let's put this right here. And in fact, I can just make a class user. And I know I need my Dunder init method, right? My init method. And what's the first argument that I always need to pass to this method? Yes.
Self.
Awesome. Thank you. And Murad, I'm here. I was able to hear you because we're in the classroom, which is perfect. Self. And based on looking at the tests, what should the next arguments be? Like in what order? Yeah, name and email and driver's license. And can someone remind me, how can I make driver's license optional?
We can assign it to equal none.
Yeah, exactly. Thank you, Murad. With any function or method, when I'm defining one, if I want an argument to be optional, I need to give it a default value, and I do it just like this with this equal sign equals none. And now, as we've learned, and can someone, while I'm doing this, remind me, why do I have to do this? Why am I doing self.name equals name, self.email equals email? What is the point of this?
To create like, oh, go ahead, Momo.
Go ahead. I'm sorry.
Is it to just create instance variables, right?
Exactly. Yeah, instance variables, instance attributes. Because what I want to be able to do now is when I create a new user, and I always love to write out little tests for myself as I'm writing my code. Like, you know, I don't write more than 3 lines of code without running it and using a print statement to confirm if it works or not. And I'll do just like XYZ 1, 2, 3. And we'll name this person Bob, no license. And this person will be Bob, and they will not have a license because there's 2 different cases in my code that I need to test, right? You can think of this like an if statement. There's 2 different scenarios, and I want to make sure they both work. And just like you were saying, like once I create an instance of this class, an instance of my user, if I want that specific instance to have different attributes, I gotta assign them to self, because self is the actual class instance that I'm creating. And now I can print out Alice, and I can print out Bob. I should be able to see all their information, except what is this red squiggly here? If I hover over it, Bob is not defined, right? Easy mistake to make. Bob, no license. I recommend trying to keep your editor clean. Sometimes the red squigglies are there because the editor is annoying. But the best you can, you should do it. But I'm not seeing stuff that's very useful printed out right now. And can someone remind me if I want to be able to see Alice's information and Bob's information, what do I have to do to make that happen?
I think you make the string the like init but string.
Yeah, exactly. Thank you, Murad. I need the Dunder string method, which is sort of a, right, any Dunder method with the double underscores is sort of a special name that Python has reserved, and it has special behavior around. And remember, this has to return a string. And let's just go ahead and do this. And we'll print the name, and we'll print the email. And we'll return self.driver's license. Any thoughts why Python was designed where this Dunder string method has to return a string instead of print it out?
That way you can just print the object or the class object itself without having to do anything special outside of that.
Yeah, totally. I can print it out. More generally, it makes it more flexible, right? Like maybe I'm doing something in different situations where I actually want to get the string returned and I don't print it out right away. But yeah, you basically hit the nail on the head there. And now if I run my code again, I get my info. And note that, how much code did I write here? I wrote 3 lines. I added in my own tests, I ran it. I added the Dunder string method, I ran it. Because, this morning during the lesson, I made a really easy mistake. I did print instead of return. If I had 10 more lines of code, debugging this would have been a huge pain. But it's because I'm running my code like every 2 lines, it's super easy to read this error message. I can Google it. I see it's from line 14 is where it comes from, but I see it's related to the string method. And so now this becomes easier for me to fix. And now, we can go ahead and run some tests. I should probably try, in fact, let me look at the README to remember how to run the test suite. So I should install PyTest. The default virtual environment that we created is there so that we should only have to install PyTest once, because we can just use that same default virtual environment for most of the assignments. As we get more advanced, that'll change, but I already have it installed. And I see here the command to run the tests. And so let's go ahead and run my tests. And it would help if I spelled PyTest right. And I am in the same directory, note, and I see that 4 tests are passing, and there are 4 tests in the test suite. So I'm good to go. And the fact that I kind of did my own tests with the print statements kind of helped me along the way. So I thought it might just be useful to walk through this, to see a little bit of this workflow, and to sort of go through this problem a little bit as a group. I just want to check in and see if folks have any questions or bits that you'd like to maybe cover or dig in on this before we move on to sort of the next bit of what we want to learn and talk about today. Murad, yes, sir. Your mic might be.
Yeah, I have a question, please. Okay, when we make print Alice and print Bob no license, okay, is it printed to the console because we make the string that when we make the class user, because we make the second function, the definition string cell? If we didn't make this step and we try to print, it will not be printed. It will not
Correct.
define itself.
Correct. That's exactly it. And in fact, if I go ahead and I run this, I see something's printed, but it's not that useful. What I see printed from lines 14 and 15 is Python says, oh, there's an object. It's an instance of the user class, and here's its memory location. But so like the reason if I do, print 5, because remember, 5, as we learned, is actually an instance of the integer class. Somewhere in Python, there is like class int. And it has its own string method. And so when Python is looking at any instance of a class and we're using the print statement, Python looks for that Dunder string method to print that out. Otherwise, it defaults to this behavior. So that you hit the nail on the head there. We need to use that to tell Python, hey, if I say print this, this is the information I care about. How do I represent this instance of a class as a string? Great question. Any other questions that folks have or things that you'd like to review? Cool. Okay, the guessing game one gets a little further on, right? And I think I'll leave that to all of you, and that's to what your team stand downs can be good for as well. Let's move ahead a bit and let's look at let's talk a little bit about getters and setters. And let me do a quick bit of cleanup here. And I think as what's going to be the easiest way to do this? So I need to pull open my slide deck. Yeah, that's not too shabby. Is this okay for everyone? I realize it's a little bit of a pain with this stuff on the left. Cool. And everyone can see my screen and they're seeing the intro to Python OOP slide deck, correct? Perfect. So this is what we covered in the first part of our lecture, right? And you all have started to get a sense of encapsulation, I think, and abstraction. Inheritance and polymorphism will come later. Right? Encapsulation, if we're writing a program to manage animals, you know, not every part of my program needs to know all the details of the dog. That's how the dog class can be useful. Inheritance and polymorphism we'll talk about later. Now we're going to briefly talk about getters and setters. Excuse me. And what are called decorators. And everything that we're talking about here, although we're learning how it works in Python, these are concepts that most, if not all, object-oriented languages have. Like if you look at Java, which is a different object-oriented language and very different from JavaScript, or C#, they have classes. And, you know, they don't, those classes, there's no Dunder init method, but I think it's called construct, right? And those classes have class instances and class attributes. So these are like computer science fundamental concepts that are implemented in different languages, but it's all variations on a theme, and same with getters and setters. So what we're going to talk about now is a decorator. And that's going to kind of be our prelude to getters and setters. And a decorator is essentially a function that takes in another function as an argument in order to then do something to modify the behavior of that function. This can help in terms of sort of making our code more composable. You could imagine if we had, I don't know, like 500 files and tens of thousands of lines of code, and we wanted print statements for logging, how it could be useful to maybe have a decorator where we could like modify the behavior of existing functions more easily. And I think, in fact, we should just dive right to this let's see some code bit. And I'll just leave this definition up here as we do that. And let me go ahead and close these out. And let's go to X-ray demos and notes. Let's go to module 2, which we're in. Day 1 of module 2, and I made up part 2 here for getters and setters. I'm gonna use touch to create the file and then code to open it up. So let me talk a little bit about how decorators work. And actually, let's go ahead and quit this because this way I can show you in the curriculum. So we use decorators to modify or enhance the behavior of our functions without behaving their actual code. There's a couple important concepts that we're going to see here. Functions are objects. In Python, functions are what are called like first class functions. I can actually pass functions as arguments. For instance, let me go ahead and make a function, and let's just go ahead and name it, say, hello. And let's have it say, hello. Well, you've all seen, I can call this function. What you all might not have seen, and quite probably have not seen, is for some reason, if I wanted to, I can actually pass this function as an argument. Because a function is an object. And now, all of a sudden, this variable holds a function and I can call it. Now, if instead, this that held 5, I'm going to get an error. Python is saying, hey, that variable, it holds an object of type integer. That type of object, that class, is not callable. But with this way, it holds a function. And we can call it. And all of a sudden, this starts to get interesting because let's say I make a function to decorate, and think about putting like the bow on a present, right? Or like the icing on a cake, like we're decorating, or the ornaments on a Christmas tree. We're decorating something that already exists. And I can have a function take another function as an argument. And it doesn't even have to know what the heck the function is.
As for terminology in the industry, whenever you have a function that like takes another function as an argument and does all this other stuff, it's called a higher order function.
Yes, that is an excellent point. And in fact, let me make a little doc string here, and we'll just put that as an example. A higher order, and actually, Connor, is that, I know it's related to something with math. Do you know where that term comes from?
No, but I think it is related to the concept of closures, but I always forget what closures mean.
Yeah,
Does this mean like has more power?
I think that's correct. I think like higher order, the same way if you have like a polynomial that has like more variables, or I'm actually going to stop right there because I'm not 100% and I don't want to just start waving my hands and get it mostly wrong. But it comes from that mathematical idea of a function that Francisco was talking about, where it's like the same input, you always get the same output. And I will, if someone reminds me, I'll try and look it up to come back with a good answer. But there's a whole other way of designing and thinking about software called functional programming that is all about this. But this is kind of cool that even Python, an object-oriented language, has first-class functions, and you can pass a function as an argument and assign it to a variable. And in fact, did we look at lambdas? I think we did look at lambdas a little bit last week. Is that correct?
Yeah, so I was about to add, so map and filter and reduce, they're already higher order functions because you pass in a lambda expression to the map function to modify its behavior. So those are examples of higher order functions.
Yeah, that is an excellent point. Yeah, and especially when we do more JavaScript, we'll be using more map and reduce. And let me just check in here and see what questions folks have or things that they want me to touch on. Okay, cool, awesome. So,
Hey, Adam,
yes, sir.
real quick, I did Dr. Google. A higher order function is just a function in math or computer programming that takes functions or gives functions. It can return or it can accept a function. That's it. Whereas the other ones are called first order functions, and they only accept like the variables or lower level. And then in lambda calculus, all lambda functions are higher order functions, which is why they use the word lambda.
Yeah, because lambda calculus is something one day that I should learn and honestly don't know at all.
So
that is awesome, and thank you, Len. And yeah, and the good news is we're not gonna. It is really cool stuff. You don't have to dive into it unless you want to. Len, however, you raised an excellent point that a higher order function could also return a function, and this is actually where this gets quite useful, because the downside of this here is like, I can call it, I can do say hello, but kind of what if I want to put this in my pocket and save it for later? Well, let's make inside here, let's create a new function and let's just call it like a wrapper, like it's going to wrap around this.
One other thing I'd like to add is lambda calculus is far beyond the scope of this course. Only look into it if you're really interested in math and stuff like that. It's pretty intense.
Yeah, that is a very good point. So now all of a sudden, this function doesn't actually call what I pass into it. It wraps it inside another function that we create in here and returns that. It's almost like a function factory, right? Because let's say, in fact, let's say I also had say goodbye. And I'm not sure what that's about. Well, all of a sudden, and now I can call both of these unless I have made some sort of typo along the way. And one sec, let me run this, Connor, and make sure I don't have a typo. And I see a couple other folks have their hands up as well. I don't know why I keep getting kicked out into the wrong directory. Yeah, so yeah, folks, I all the time on the command line, ls and pwd are my best friends. And hitting tab to autocomplete because I make a lot of typos. So I use tab to autocomplete all my file names. So here we see, if I walk through what's happening here, actually, someone want to walk me through what happens here on line 24? Does some brave soul want to give it a shot?
Yeah, I'll give it a shot.
Awesome. Thank you.
All right. So say hello decorated is being set to my decorator with the argument of say hello.
Yeah, so walk me through. I haven't explicitly told him.
Scroll up for me.
Yep.
Sorry, scroll up. Oh, that works too. All right, so we're setting from what I'm seeing, it looks like we're overloading the my decorator method, but what we're doing is we're calling my decorator and we're passing in print hello. And so what we're doing is we're decorating the response of the function with two logic statements, one before and after. So we're saying do something happens before the function, then we're gonna say hello, and then we're gonna do something after the function happens.
That is an excellent description of what's going on and talking a bit about kind of what's going on under the hood. Let me show too how to sort of like walk through the flow of execution, and I haven't really talked about this, so this is probably new to a lot of folks. And what I mean is like, and this is where like using a debugger can be helpful, but like, you know, when I was studying computer science, they would have us like write little programs out on a piece of paper or on the whiteboard and like walk through it line by line. And it's basically, you gotta sort of in your mind simulate line by line what the computer is doing, right? What is the Python runtime doing line by line when we run this code? And let me actually walk through this because this is a good thing to see, I think. So when we run this program, and Brandon, thank you. And Connor, I know you had your hand up too, actually, so let me check in real quick.
Yeah, actually, I was gonna say, this is actually, when I was first learning this, is a very abstract concept and it took me a while to learn. Could we get like a visual like demo of like what the functions are doing so that others that might not be grasping the idea can visually see like, oh, here's the input to this like box and here's the output to this box, like that, something like
Yeah,
that.
that is actually a great idea. Thank you. Let me go ahead and let's do that in TL draw. And I'll do my best to sort of draw that out. So let's say this is my decorator. And let's use, where is it hiding? We'll just use a downward arrow like that. And there we go. And let me standardize sizes a bit here, folks. Give me just a sec. Not sure. We'll see. We'll see how well I do at this. And we'll make this green, and we'll make this say hello. And I think we'll make this smaller. So I'm not sure if this is, hopefully this will help a bit, but we are literally taking, we're not calling say hello, we're passing like the reference to the function itself into my decorator, and then that's going to create, and let me get another box going here. This new function named wrapper, right? And what this function does is print, you know, I'm just going to do print A and then say, and let's put maybe here like func, right? Def my so that this is the argument name that gets passed in, which in this specific case is say hello, but it's really the argument name function, and then print B. And then this spits out as its output. And let's make the wrapper blue. Oh, let's make this blue. It actually spits out this wrapper function here. And actually to walk through this line by line, which is where I wanted to go, like when I run this file, top to bottom, what does Python do? Line 1, it says, oh, I have a function. One moment, Mikhail, and I saw someone else up with their hand up as well. I'm gonna save this function definition in my pocket. Oh, we're defining another function. Okay, I'm gonna save that function definition too. Oh, what am I doing here? I'm taking this thing, say hello. Oh, I have that. That's a function. Let's assign it to this variable. Cool. Oh, let's run a print statement. I need to grab the type of this. type is a function. It's going to return a string that's the type, and that gets returned to this print function. And then that gets printed out. And then the Python interpreter moves on to the next line, and it says, oh, this var holds a function. Someone's trying to call it as a function. Let me see. Oh, it is a function. I'll call it like that. And then the Python interpreter keeps on going. It ignores comments. It says, oh, here's another function named myDecorator that's getting defined. All right, let me file that away. And then over here it says, oh, what's happening? This myDecorator function is getting called, and this thing named sayHello is getting passed in. Well, let me see what sayHello is. That's a function definition. Let me feed that into the machine. What should I do now? And so from here, the Python runtime, the flow of execution jumps from line 24 to line 16, right? When this is getting executed. And then it says, oh, I need to create another function. And this is what that function should do. And then it creates it. And then it says, oh, I need to return it. And it goes ahead and returns it. And then flow of execution continues. We hit line 25. It goes through the same process. And then here it says, oh, I need to actually call this thing. And then we actually call this wrapped function. And I see a couple of hands up. Mikhail, yes, sir.
I was thinking you can actually just do the debugger if you just click line 27 right there. And then by the arrow, you click the down arrow and then click Python debugger. Yeah.
Let's see if this works. That would be great. Oh, yeah. Perfect.
Up there. So at the top, just the down arrow. The down arrow.
Step over or step into.
Step into. Yeah,
Yeah.
that works. And you'll see, just keep pressing that down arrow and you'll see every line.
Perfect. Thank you. Yeah, so folks, so in the debugger, you can click on lines and add what's called breakpoints, where it will actually stop the running Python program. And here we can see all of the variables that are a part of this program and their values. And if I want to, I can add a variable to watch. And like they were saying, I think if you use the step into command, it will go step by step. And thank you so much for the walkthrough, because to be honest, I don't use the debugger and breakpoints a ton. I usually use print statements, but it is quite useful to walk through this and kind of see the flow of execution, though I don't want to go too much into it now.
Yeah, and you can see it print out everything when it reaches the lines. You see it in the terminal. It's printing out everything.
Yeah, that's awesome. Nice, thank you. I appreciate it. And Chris, yes, sir.
Yes. So in line 24, where you says say hello decorator, my decorator, say hello. Or say hello, could you just also reference this var holds a function, and would it do the same thing?
You are absolutely correct.
Okay, and then what was the point of reassigning it to another variable?
Over
it
here?
just yeah.
Yeah, just to show an example.
Okay. All right, and then for the function def my decorator, so you put say hello function into it. So it will also print out hello, and then something happens before function is called. Right? Or no, is it between these two print statements is where hello will say? Oh, is
Exactly.
Okay.
Exactly. And if I go ahead and run this and I have to
go back.
Yeah, it opens a different terminal. I just need to, there we go. Now I should be in the right spot.
Gotcha.
And in fact, let me just comment out
Comment those.
yeah,
okay,
so
yeah,
all
because
we
that first
see-
hello. You're right.
Yeah, so you hit the nail on the head.
Okay.
Yeah,
Gotcha.
great walkthrough of the code, man.
Anytime. Thank you.
My pleasure. Thank you. And then we have the exact same thing going on here, but we pass a different function into our decorator. Right, so now it will say goodbye. Daniel, yes, sir.
Me and Garrett have the same question. So I see you calling my decorator, but how are you calling the wrapper?
Great question. So note that my decorator returns the wrapper function. So right here on line 25, that wrapper function is returned and assigned to this variable. Say hello decorated. So
So it's being passed as a reference.
it's not being passed as a reference. Maybe it's being passed as a reference. I don't. Yeah, it probably is. Though that is a little more than we don't quite have to worry about whether it gets passed as a reference or passed as a value. Though it probably is being passed as a reference. That is probably how functions get passed around, but I'm not actually certain. The important thing is it's getting passed, right? Either way, that this wrapper function is returned as a variable and then assigned to this other variable.
This might
Does
clear
that
up
help,
some
Len?
confusion. Sorry.
No, no worries. And Daniel, please go ahead.
No, that was my question. Thank you.
So I'm about to say something that might clear up some confusion. So basically what the way to think about this is whenever you call my decorator and you throw in a function into it as an argument, it will return another function. So if you go ahead and call my decorator and throw in any kind of function, you'll have it like, it will just return another function. So you can just call wrapper by putting another set of parentheses after it. You get what I'm saying?
You're saying like if I wanted to over here, I could do this.
Yeah, so yep,
Yeah.
exactly. So that's exactly what's happening. The reason why this works is because my decorator returns wrapper, which itself is a function. Okay. So basically you can replace my decorator with wrapper and it would be the same. And that's the whole concept of this. It's a little bit confusing, but if you mess around with it, it will get easier.
Yeah, I wouldn't quite put it that way, but I think you're on the right track. And definitely, yes, if you mess around with this, it gets easier. And I do recommend just writing this out and playing around with this a little bit. Just writing functions that return other functions. You know, like you could write a function like def return, say what, and you could just do def say what. Like you could play around with this if you want. But I do want to move on a bit. Because now that we've seen this, I want to show us the Python decorator and getters and setters on classes, and I want to make sure that we have time for that. Chris, I did see your hand up, so let's take that question and then move on.
Yes. So when we was in that break room, Connor was telling me, well, this is really a question for Connor. You were saying that we should always write code or write a function that does one specific thing so other people can read our code. So, but in this concept, this function is calling multiple things. Would that confuse, like how, if we are going to combine all functions and everything, should that be at the end of defining each function that we write and then put
I don't
all
want
that?
to get,
Okay.
I don't want to get, it's a good question, and I don't want to get too deep into it. Short answer is, the reality is you probably don't want to be writing tons of decorators, especially starting out. We are going to be giving you some assignments where you should do them. This does do one thing. It imagine that, we always wanted to say the same thing before something was printed, right? This is the one behavior. It's just we can use this to add it to a lot of different functions. But I don't want to get too deep into that right now. And I think the short answer is, like, we'll kind of be telling you when to use this for this week. And just in general, like simpler is better. Like just as a general design principle, especially starting out, just I think trying to keep things simple is a good way to go.
Thank you.
Yeah, totally. And also because to be honest, talking about design gets like very nuanced very fast. Let me go ahead and show how Python incorporates this decorator behavior to make life easier for us. Right, and a decorator is a higher order function. But what Python lets me do is using this special @ symbol. Let's just do say I already used say hello. I already defined it up here. So I do apologize. This is going to vary from the lesson a little bit, but I think you all will be able to see it. Say something. And we're going to get rid of that. And we're just going to print something. And I don't want to lose that, so I'm going to leave that stuff there. And sorry, I just want to get all this in our notes. So instead of having to call this function this way and do all this stuff, if I know that I always want this to happen every time I do this with this say something method, I can use this @ symbol to apply my decorator. And it's called syntactic sugar. It's like a nice way of writing this. And now if I call say something, fingers crossed, we should see our message. You know, and let's do another one real quick. Right, so if, you know, I always wanted, so this way, to kind of go back to your question, Chris, this is, you know, I skipped over composition because it wasn't in the slide deck, but this really does let us compose and combine these pieces because I have this behavior that for some reason I want to happen every time, right? Maybe it's like some error checking, maybe it's validating a username, maybe it's like logging something to our log server every time a user logs in. But I can put that behavior that I care about in the decorator function and apply it to functions that I care about in multiple places in my code. And then, you know, if I change my mind, super easy to change without having to do a ton of changing to whatever is inside this function. And yes, I saw a couple hands up.
I think you just answered the one that I was going to ask. Thanks.
Okay, awesome. And let's start adding some of this stuff for getters and setters. So we've learned about decorators, and I just want to check in. How is everyone feeling on decorators, on sort of the basic concept?
I have a question. Is getters and setters a form of decorator? Are we going to go there, or is it's not the case?
That is exactly where we're going.
Okay, just checking.
Yeah, I love it.
I'm sorry, Alan, can you give very simple example, 2 function, 1 decorator, taking function and give the 2 output? Not too many steps, just like.
I think I'd be happy to go over that again towards the end of the lecture. Right now, I think I want to make sure I move on to getters and setters. I see a couple hands popping up, and actually, if you all don't mind, please put them in X-ray questions so I can look at them and cover them, and also kind of make the judgment call if it's germane to what we're about to get into, because I do want to make sure to cover this. So we've learned about decorators, and we're going to use decorators for getters and setters for classes. What are getters and setters good for? Data validation, like say validating if an email is valid, maybe a little bit of transforming data, and a little bit of access control. Like maybe we have some data in our class that we don't want other classes to interact with. So I think the best way to get started is to follow this convention that we're giving you of when you create a getter, define it with get, and then with a setter with set. And I think the easiest way to show this is just to put it in action, to be honest. So let me just go ahead and write a little code. So we're going to create a person class. They're going to have an init method, of course. And that person will have a name and an age. Now, I'm going to make class attributes, but I'm going to put one underscore in front for name and age. Because we're going to see how to use getters and setters so that when I'm using this class and an instance of this class, I don't interact with the underscore name and underscore age instance attributes directly. So this underscore is a naming convention. Python doesn't actually do anything with it. This is for other programmers, but this is sort of how everyone who writes Python code writes their code, and they'll see what you mean, and you should follow this convention. And now let's see what this looks like. Let me go ahead and write an instance method, get name. And at first, this looks normal, right? And let's go ahead and make a user. We'll make Alice, and Alice is 25. And I'm going to give Alice a dunder string. Well, we'll get there. We'll get there in a minute, actually. So we'll just print Alice. So I can do this, but
It's a person.
I shouldn't. Yeah, thank you so much. That should be a person, not a user. So there's nothing stopping me from doing this, but if I'm reading someone else's code and I see that these instance attributes start with an underscore, that's them telling me, hey, there's a good reason I don't want you to do this, right? Maybe the reason is, and let's go to ChatGPT, my friend ChatGPT, and let's see, Python, capitalize first letter of string. We use the capitalize method. Perfect. So maybe the reason is, for some reason, whenever we want Alice's name, we always want to capitalize it. And I feel like I'm probably using that wrong. Let's see what ChatGPT says.
It's
it's
dot
just
upper.
dot upper. Yep, that would be what I'm doing wrong. Where now, if I run this and instead of dot name, I use, if I call this method get name, upper, that's not what I want. I want capitalize. And this is why it always pays to not entirely skim the docs. right? Because maybe I've decided whether the input is first letter uppercase or not. I always want that to be the case when I get the name. Or there could be some other reason. That's just an example. So this is a little bit of a pain though, because I have to call this method. And that's where decorators come in. And Python classes have a special decorator named property. And if you put this on a method, it lets you treat it like an instance attribute. So just like if, say, instead of get name, I named this just name, then all of a sudden, this is really nice, right? I have the actual value stored in underscore name. It's kind of protected. And I have this property decorator that lets me write a method to do stuff, but use it like an instance attribute. So it's a little easier. What we have in the curriculum and what we're going to ask you all to do is we're using just get and set for getter and setter names to get started, because I think it helps make it just a little easier to get used to what each of these is doing. And let me just take this home and then take some questions. And similarly, let's say I need to change Alice's name. Well, maybe I make a set name method. And maybe what I want to do is I want to add, well, first of all, it should take the new name. And maybe I want to add a little bit of conditional logic to make sure that the new name is indeed a string. So I'll use this isInstance method to make sure that the new name is indeed a string. And I'll set name to new name. But maybe what I want to do is lowercase it all the time. So that if, say, Alice set name Bob, I don't want Bob in all caps. I want Bob in lowercase, right? And in fact, if I print out just for fun, even though this is not what we're supposed to do to show you, right now I've got my name stored in all lowercase, which is nice because that's flexible. And if I'm doing string comparisons, I probably need to lowercase everything anyway. But when I use the get name getter, I can have the first letter capitalized if, say, I'm printing this out to a user or something like that. And then what we can do is there's another Python decorator that goes along with the property decorator called a setter. So that instead of having to do this, just like how the get name property, I can treat like an attribute, it's not a method that I'm calling. I can do the same thing here now as well. And so if I wanted to, this could become name, and this becomes name, and this becomes name. And all of a sudden, it feels exactly like interacting with some instance attribute property named name, except we're using getters and setters. We do have in our curriculum right now, we are using the convention of get name and set name. And I do sort of go back and forth on this, but I do think it's good for learning purposes to start with this. So this is what we're going to do for now. But I just sort of wanted to walk through and illustrate that. And I do see a number of questions. So let me just dive in and take a couple questions. And Chris, I know you had a question, sir.
Yes. Okay. First question. For line number 2, I see is 3 parameters, but you're only for line 19, you're only calling for 2. So do Alice go into self, or does it? Well, I see you have. So what's the point of that? If you were saying self is okay.
When Python does something a little special and magical with self, with class constructors, like right here, or with class methods, Python actually will pass in the first argument for self. You can think of it, Python sort of hijacks it a bit, and it passes in the actual instance of the person class. So Python takes care of that for us.
Okay.
Let's see, someone else. Connor, I just want to make sure I hit the student questions first. I think someone else had a question, but I might have lost your hand. If so, please just shout it out.
So okay. Well, so what's the can I just use name for like if I take self out and just use name and age, can I just use name for get name and put name there and things like that?
You can. To be honest, that is indeed the industry convention because that's where you sort of get the niceness of it. We're talking about updating our curriculum to match that. We've sort of done this because in the hope that for introducing the concepts, it makes it a bit clearer. The only thing I would just say is like we have a bunch of test suites and on the assessment and stuff where we're probably going to ask you to name it this way with like get underscore and set underscore. And Connor, I know you had something on your mind that you wanted to share.
I actually have a question. So, in like the industry, what is the standard for applying all these sort of transformations? So I see here you have like a capitalized in the get, but then you have a lowercase in the set. I
Yeah.
feel like that would be quite confusing because you would think, oh, so it's just gonna be lowercase whenever I set it, but then it comes out capitalized, so it's like different than what your expectation is. So would you prefer to put all of the transformations in the getters or in the setters?
Great question. I think here is maybe a bit of a better example. Let's see, Alice, I don't know. Waters. And let's just do set last name. And in truth, what I really should be doing here is maybe self dot set name, right? Then I can use my validation logic in the constructor. Set last name.
So what you're saying is you want to put all of your like data transformation rules in the setters, and then the getters will just get the raw data without doing anything.
Give me just a moment. Give me just a moment to get to that question because that's it's a good question. So this we actually want to be property. So get last name, property. We don't need new name because we're just giving the name, and we're returning self last name blah. Get last name setter, and now we want that to be. So let's say for the sake of argument, I don't want to capitalize. I don't want to capitalize the first letter of the first name and the last name when I return them. But maybe what I want to do is maybe I want a method that prints out the full name that's going to the user interface, like the browser or the terminal or whatever. And so now all of a sudden, maybe what I do want is something like this. So it really, it depends. Like basically, you can use the great thing about storing text lowercase is if I need to do a comparison, everything's already lowercased. And I can push like my formatting logic, say for showing stuff to the user into getter functions that are specific for that. So it really depends, but that's kind of how I've seen it used, because this becomes quite useful, right? And the reality is, this underscore name is still there. It's still accessible if I want it. So, if I knew the context of the code I was writing, like if I knew that what we were doing 99% of the time with this was displaying the name to the user, and I always wanted that first letter capitalized, then I would probably do that. So it's there all the time. But that way, like if instead, say I have to compare first names self, like if self name equals other first name.
Okay, so to summarize, basically what my understanding of this now is, you want to have all of the data normalized first, and then like for like the regular getters, you can just get whatever the normalized data is. However, there might be certain cases where you need a special getter where it gets it in a particular format that you want, which is different than whatever is standardized.
In essence, yes. I think what I would say is getters get you flexibility.
Got it. That makes sense.
Yeah, great question. And I know that was a bit into the weeds, folks, as well. But yeah, excellent question, Connor. And Cody, yes, sir.
Awesome, thanks. Hey, a quick question. So what's the difference between line 14 and line 24? Like the at property versus the at get underscore name dot setter, and then like, do you need the dot setters, like the dot setter a variable, or is that Python says that has to be setter?
Yeah.
Those just confuse
me
a little bit.
Great question. So if we go back to what a decorator is, remember a decorator is just a function, and then Python sort of gives us this syntactic sugar with the at symbol, so that instead of like having to like pass this function into this to return the other function, this will do sort of all that wrapping for us. So this at stuff does get a little magical, but that's sort of what this at property getter is doing, right? This is a decorator, and it's adding sort of an extra thing that lets us access this like a property. And as you noted, this setter decorator is even a little more magical, because you're totally right that, and in fact, let me just grab this and put this right up here next to it. If this doesn't exist, this will break, because the convention here for a setter is the name of the getter, which has to also have the at property decorator. Otherwise, this setter will break. And then dot setter. So that's kind of why like getters and setters go together. Like I might have a getter without a setter, and this is like some terrible nursery rhyme now. I might have a getter without a setter because all I need is a getter, but I would never have a setter without a getter because that would break.
Or you could just use get name, set name, and then leave it at that too, for simplicity's sake.
Say that again.
You could just have like get name, set name for simplicity's sake. You don't have to get into all the property stuff, You could just
have
also
them be
write,
methods.
yeah, just create another method like get capitalized name. Like you could do that too,
Yeah.
instead of all of that.
Yeah, you could. We are going to kind of require you all in a bunch of the assignments to use getters and setters. And again, to be honest, like the real simplicity here is when you name everything the same, because that's when this starts getting a lot easier to use. But to be honest, we also got feedback from folks when we were introducing this stuff that this gets a little confusing. So we've kind of been on the fence of whether to just dive right into the industry naming convention or not. So this is what we're using for now. And the reason that we do push getters and setters with these properties is first to get you using decorators, because they'll come up later in Django where there's other things that we're adding decorators for. It is a very useful thing for object-oriented programming. And second of all, just to get you introduced to some of these concepts and like object-oriented design principles. But yes, the reality is for object-oriented programming, until you're working on a big code base, you don't really need this stuff. Like for little programs, all these design principles don't, the code is too small. But they're important to learn, so they're a little bit of forced examples so that you learn them. Did that help at least answer the question about the naming conventions of creating a setter and why it has to be named this way?
Yeah. So I guess I'm a little confused there. So yeah, that cleared the naming portion up, but the at property, where are we defining at property at?
Great question. We don't have to define at property. That is a built-in Python decorator. So the same way that we created at my decorator with this function here, somewhere if we dig into the Python source code, there is def property. And that decorator has been created for us and is part of the Python standard library that is specifically meant to be used with class instance methods, just like we're doing here. Does that?
And so that enables 34. So you made 30, and that
Exactly.
enables line 30.
Exactly.
Because you named it get last name.
Exactly.
Okay, I think I'm following now. Yeah, that logically makes sense. Thanks.
Yeah, great question. Great question. And this does get us a little deeper into the Python language, right? And I saw a couple of hands up. Joseph, yes, sir.
So just to clarify, the whole point of that property getter or decorator is just to add a layer of encapsulation, and that so that you can call those functions, the get last name, as a method of the person class. Is that, if I'm understanding that correct, are those like the two reasons that you would use the property decorators?
Yes, I think that's, yeah. And I get that it's a little, it can be a little trickier to think about. It for formatting and for encapsulation, because because you raise a really good point, actually. Like, you know, let's say there's a lot more code in this class. Let's say it's a lot more complex. Let's say for some reason, the name of this underscore name variable in here has to change. Or maybe for some reason, I don't know, like, I don't like, maybe because we're going global and we have to deal with naming conventions across languages, and, you know, not every culture, like the first name is the surname, or just names get more complex and all of a sudden it can't just live in one spot. And we have to change this stuff. Well, if I don't have this getter, get name, like think, and let's say that, like, you know, this class is being used in like 30 different files in a big application. And so the nice thing about having this get name property is we could change this to be, you know, whatever. And we could change whatever we need to inside this class, but then in those 30, 40 other places in the code where this method is used, that name doesn't have to be changed. Those tests don't have to be written. That code doesn't have to be reviewed because we've changed it. So that is also sort of like encapsulation, like you were saying.
Okay, thank you.
Yeah, totally. Yeah, great question. Again, for like smaller programs, the examples are a little contrived, but I think you all are on the right path, and I hope that these are helping a bit. And that scenario that I painted is very normal, by the way. Like most code bases are big, like legacy applications that have been around. You know, if a code base has been around 5 years, it's a legacy application and it's got tons of bad code and warts. And so changing this might actually be a massive pain. And so that's where part of this comes from as well. You know, because what if we had, you know, I don't know, let's say self dot just something, some property, and this was used in like 500 places in a massive code base, but all of a sudden, like how we got this had to change. Well, if I go ahead and I write a property you know, and I make this, you know, a private variable that comes in or is got in some other way, all that other code, it doesn't know this has changed. From the perspective of the other people using my code, it's still alice.foo. So that's an example as well that this is getting a little far afield, I apologize, but of the value of in real world code bases of encapsulation and sort of having these tools. Chris, yes, sir.
So, okay, for property, if you remove property from whatever these functions and try to use that function outside of class within the file, it just won't work, correct?
Yeah, I mean, like here's foo, right? Let's watch what happens with foo as we play around with this.
Okay.
Let's see, where's all this? What does it not like? Maybe it doesn't, maybe it actually doesn't like me using the setters and getters in the constructor. I might not actually be able to do that. I might have gotten ahead of over my skis there, which is fine. We'll just do aim and that's it. And I guess that just like I should have followed my own advice and ran that code after I made that change. So right now, and let me do a split here. And let's make this bigger. So right now I've got this property foo, right? And I'm just having it return a hard-coded string. It could be whatever we want. Watch what happens if I get rid of the at property decorator. All of a sudden, bound method person foo blah 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 blah. What's going on here? It's returning the method, but it's not calling it because all of a sudden the property decorator hasn't been applied, and this looks like any other instance method to Python, right? Which means if I want to use it, I gotta call it. So that's what the at property decorator gets us, is it lets me take a method, but treat it like a property, and then it lets me do like more complex stuff. You know, if for some reason we always needed to print about to return foo. So it's sort of like a middle ground because there is a point at which maybe this is meant to become a method, but that's what the at property decorator does. And now if I do this, in fact, I get an error. String object is not callable because Python sees this string and it treats it like an attribute. Does that? I'm not sure if that directly addressed your question though, Chris. So I want to check in.
I see that it's important to print stuff out correctly. So I'm gonna just use property to print it out. But I see where if you don't print it out, it will give you that where it was stored at in memory. So okay, it's an indicator that if I'm doing something wrong, if I get that to put property on top of my function inside a class. Okay.
Yeah, exactly. Absolutely. Great question. And Len, I know you have a question, and then we should probably break because I have ran long. Yes, what's up, Len?
Okay, I'll try and be quick. I want to kind of synopsize what I've heard so far from the very beginning. So this might be a good place to end. You started in the class person and you put the underscore in front of name, last name, and age, which is just syntax to tell code users that in this thing, you don't want to go in there directly to do these things.
Yeah,
so in order to do that, you create these external functions, which are the setters, and which will become called the setters and getters, right? But they're just like defs. There's regular defs out there. And because as decades go on or years go on, other people are going to be messing in the code and using those things and could use them differently or have different names. Python has created this magic thing called the property that you can add to it that helps to make sure that I don't quite understand yet, but I will because we're going to go down the road. The code still works right by using that function as a property. Did I get
Yeah,
that?
I think you pretty much have it. It's not unique to Python either. Most object-oriented programming languages
Just
have
the way,
this.
just the way Python does it. This is just the way they do it.
Yeah, yeah. In other languages, it's often like they maybe decorators are in other languages as well. You'll see them used like this.
Mm-hmm.
And again, this might help a bit. Like if we change it instead of like name and set name. Like if we, because this is where it becomes nice, because I can write my code just like I'm using a normal instance attribute, but actually, since this is a setter, I get validation checking, right? As a getter, if I wanted, I get a little nice formatting here, but I can just do like alice.name.
Okay.
Yeah, you're not wrong. It does add an extra layer, and the value of that extra layer, I think, is a little harder to see with smaller code bases.
Right.
But it is important stuff to learn, and it's not unique to Python. This is sort of our introduction a bit more into stuff that is a little more, I hate to say magical, but it is a little more magical, right? We're getting a little deeper into the Python language and how it works with classes and stuff. Just remember that even though this feels a bit weird, at the end of the day, we actually learned how to do this and make a decorator.
Mm-hmm. And we'll see this again in Django, and that will probably add a little clarity. I'm hoping. It sounds like when we get there, because we got exposed to it here, it should start to make a little bit more sense.
Yeah, you'll see it like I don't know, what's a Django decorator example?
Oh, we can wait till we get there. I'm okay. I just want to make sure that we're going to see this again, and like it's part of this is like introducing us to the concept so that it's not brand new there, and we got to go through it all.
Yeah, like here's a good, actually, without going too deep, this is a good example. Like we're writing Django code, and we're going to learn about different kinds of HTTP requests, like maybe a post request to like create a user account or send form data, or maybe just send a request so you can use like a decorator and apply it to a function so that, without going too deep into it, or if you think about validation logic, like, and you always wanted to use the same validation logic for email accounts, maybe for whatever reason, it's easier to put that in a decorator than as like a function that you import somewhere. All right, I realized that we went a bit long, more than a bit long. These are great questions though, so I did want to dive into them, but we absolutely should stop so that people can take lunch. The decorators and getters and setters, I think, are always a bit confusing for folks. And just to reiterate, I think right now the important thing is getting used to the mechanics, getting used to using them, and just file away in the back of your head. They help with data validation, with setters, like validating input. They can help with transforming or how we format and present data. So like if I want to maybe have some things be all lowercase and sort of controlling access to stuff and getting used to this syntax. Because what we're going to be doing is like if you go into some of today's lessons, we very explicitly tell you what we would like you to do. Like for this student registry assignment for this afternoon, we tell you what should be a getter and a setter. And this is a little bit of like learn by example. Like we're going to show you a pattern and we want you to learn that pattern so that later on, then you can use that pattern as a reference when you're designing your own stuff. And that's also what the assessment is going to be like, where we'll be pretty explicit in our spec of like what should be a getter and a setter. In fact, we're very explicit. And that's part of the learning curve too, is learning how to write code to a spec, right? So that's really the goal for today. There is also a reading assignment in the book that Francisco mentioned he really, really, really liked. I am a huge fan of this book as well. So please do actually read this, and we have a very good stretch assignment for you all to do that's a bit more open-ended. That is not, I think, so much about getters and setters, though if you want to use them, you can. So that's really the agenda for today. Francisco and I are going to demo pair programming, in fact, in an hour. So we should wrap up so you all can do lunch, and then you'll have some work time and team stand-downs. I'm happy to stick around for another minute or two to answer questions, but I do want to make sure we can break and go to lunch. Any kind of like immediate logistical questions about the rest of today that folks have that we should tackle? Okay, awesome. Let me go ahead and stop this.